All right. So predicting rigid transformation. So we went over what were rigid transformations, mainly the idea of rotation, reflection, and translation. Now we're going to talk about predicting it. So where they go essentially. All right. So again, just watch the videos on your own. Let's take a look at what the objectives are for this lesson. So in this lesson, we're going to predict the result of a transformation and specify the sequence of the transformation. So our goal then is to figure out where the transformation is going to go, and also like how can we write down a sequence of transformations. In other words, write down instructions to make that transformation happen from one figure to another. So an introduction of this is like kind of moving an idea or copying something. So if you have like a house, how to reflect the image so it looks the same. So that's how it's used in architecture. It's not load. There we go. So one example is translation. If we move this to over there. So one thing you'll notice, and you probably have noticed it from the GeoGebra assignments, is we'll always do that prime. It always puts kind of like an apostrophe next to the letter, just to kind of show that this is the first image from this pre-image. And then there can be other transformations after that. So results from a single transformation. So we're going to look at single transformations as soon as my computer loads. There we go. I don't know why it keeps freezing. Let me refresh. Okay, apparently Admentum's taking a while, but while this is loading, if you guys haven't had a chance yet, go on the chat and answer what is something you've learned this week. Doesn't have to be geometry, doesn't even have to be school related. That's how I'm going to start taking attendance. Okay, cool. It loads. All right, so here, first things we're going to do is predict what will happen to the coordinates of x and y when we do this. So we're going to reflect what's going to happen here. So we're going to go on here on single transformations. So here's my thing. And if you guys ever want to see where the points are, you can look right here. This actually tells us what the points are. So you can always make this bigger or smaller. If it's not showing up, so if this ever doesn't show up, let me see if I can close it. So if you have it like this, where it's not showing up, what you can do is you click this little shape. And then what you do from there is you go to, where was it? There it is. You click these three little dots and go to algebra. That pops up all of this right here. So first things first, they want us to do reflection over the x-axis. So we're going to go over here, make sure we click reflection about a line. We click the whole shape, not just the point, the whole shape. And then we're going to click the x-axis, and that's going to make this little image here. And as we can see over here, we see all the points that have changed. Can you guys hear me okay? Because I think my mic kind of made a sound. Okay, cool. Thanks. So that's what we're doing here. We're just reflecting. So if we look at this, we notice that the y kind of changed sign. Before it was negative, and now it changed into a positive. So when it's asking what's happened to x prime, well, x prime stays the same. I know in this case they look negative, but it stayed the same. So we're just going to write it down as x. It's still x. Well, what happened to the y? Well, we said the y changed signs. So in other words, we're going to put a negative there to kind of show that it changed signs. So that's all we're doing there. And now we want to reflect over the y-axis. So I want to reflect this shape over the y-axis. So I'm going to do reflection about a line, click my shape, click my line, and then if I look at my points, I'm going to ignore this one and start focusing on this one. Well, it looks like my y stayed the same, but my x changed. So here I'm going to leave my y the same, but since my x changed, I'm going to put this as negative x. So we're kind of using variables to take place there, right? Now they're asking us to make this line of reflection, this y equals x line. So what we can do here, there's two ways to do this. We can try to figure out how to make y equals x by graphing it, or we can do something like this. We can literally type in, how do they classify lines? Oh, they don't. We can type in y equals x, hit enter, and then we see this line right here. So right here at the input, that's where I type the y equals x. So what I'm going to do the same thing I've been doing, click my shape, click my line. Now I'm going to take a look at this. So it looks a little weird. That's why I recommend looking at these points. So I'm going to ignore these two. I'm going to focus on this. And if I look at here, it looks like they just switched my x and y's. Let me pull my pen out to make this easier. So I'm looking at these two. So if I look, it looks like my x and y switch spots. So in order to symbolize that, what I'm going to do is I'm going to write my x is now my y, and my y was what my x used to be. So they're saying, what is your x prime? Oh, my x prime is what my y was. Well, what's your y prime? What my x was. So that's all we're doing for that one. If you guys don't like looking at all of this stuff, but at the same time you don't want to undo everything, you can actually do this cool little thing over here where you just click this and it starts hiding everything. So all you do is just click the little circle. I don't want to get rid of my B. It does take a bit of work, so it depends how picky you are about seeing it. The big thing that you're probably not going to want to see are the shapes themselves. So you can make those kind of just disappear. The points, again, that's just like a little bit of extra work. If you really want to get rid of those points, you can do that. But that's just an easy way to do that. I am going to want to get rid of this line. So I'm going to go over to line and hide it. And that's because I'm going to put another line. Now they want me to put the line y equals negative x. I'm just going to go here, y equals negative x. There's my line. Going to reflect. So it's already selected on reflection. Click this. Click that. Boom, there's my new shape. And now I know I can ignore these because they're no longer highlighted. So I'm only looking at this, and this point. What's happening between these two? Well, it looks like not only did they change my y become my x, but they also change signs. So I'm going to kind of leave it the same, but instead of just y, I'm going to put negative y. Instead of x, I'm going to put negative x. And that's what we're doing. That's how we predict what's happening. So now if we ever have any object and we're like, we'll reflect over the x-axis, we don't have to actually go into GeoGebra and do it. We can just look at this. And I recommend if you guys are keeping a notebook, write this down because there are going to be points like when you're taking a test or something where this information might come in handy. Hint, hint. It just makes it a lot easier. So, for example, right here, what's going to happen to my point A if I'm reflecting over the x-axis? Well, according to the notes I just took, My x should stay the same, but my y should change signs. So what I'm going to do is I'm going to leave my x the same, and I'm going to change the sign of my a. That's what's happening here. You can verify it by looking at the reflection that we did over here. So it's either way, but what I like doing is kind of looking at my rules. My next rule said that my x changed sign, so I'm going to change the signs because I'm reflecting over the y-axis. My x changed sign. My y stayed the same. So this stays the same. This one, we're going to change the signs again. So I'm not going to go over all of these guys because, again, I want to try to get into the unit activity for you. So I'm just going to do point A. If you want to do point B, all you have to do is grab over here. Oh, point B is -2, -2, comma, -1. And then you're going to do the same thing. You're going to flip these, change the signs where you need to change the signs. Basically the same. These things expand, by the way. So if you're like, it doesn't look like there's enough space, they expand if you write more. All right, so now I'm going to flip my x and y. So now it's at -2, comma, -3. And then the other one was they changed signs and they switch. So it's a switch and change signs. So this is a 2, comma, 3. So I'm looking at my original, changing signs, doing that. Is this making sense to everyone so far? Cool.
Kind of. It's going great, Victor.
Cool. All right. So line of reflection is this. So check the predictions on the lines, then reflect it. So this one we were supposed to guess what happens and guess it. This is literally the same thing, guys. They're just repeating it. I didn't want to get into the whole guessing because I'm like, what's the point of guessing when we can actually do the work? So I'm going to see if this works. It only copies one cell at a time, but basically what you're going to end up doing for this one, guys, is literally just grabbing this, Control C. If you're on a Mac, Command C, pasting them over. So you're literally just grabbing all of your answers from here, one at a time, unfortunately, and just pasting them over. That's all you're doing here. Because one of them was supposed to be a prediction, one of them the other one. But guess what? If you look over here and you verify your answers, it's going to be the same thing. You can see that they're the same thing as our prediction. Because we went through this, we played around with it, and we figured out what happens. Compare your answers. Did the patterns reflect? Yes, they did. Because I experimented with them a lot. So we did all the experiments with them. So that's why we were able to kind of predict it correctly. Here, now we're going to do rotation. So what I'm going to do here, I'm going to save mine. So I'm going to click share. Going to write my name on it. Let it save. Copy this link. And I'm going to paste it onto here just so my teacher can see that I actually did do the experiment. So if they're ever like, did this person do the work? It's like, well, they left the link to their thing, so they must have done the work. And because it has your name on it, when they click it, they'll see what the file name is. It's like, oh, that is them because they wrote their name on it. I don't think they copied someone else's that had the exact same name. So I don't need this anymore because I saved it, and I can always put my shapes and points back if I want. So if I ever want to put these back, I can just click it and get all my shapes back. Oh, give me a second. When you're doing this though, guys, I done goofed. You want to make sure that when you're doing it, you're on mouse mode because I had it on reflection mode, so it kept reflecting everything. This just adds them on a lot easier. Oh, those are just lines. Well, if I want to do the shapes, I would go to, where's polygon? Polygons. So that's how you can add the shapes. All right, so now we're going to do rotations. I'm going to close this, and I'm going to want to do these rotations. Well, luckily, if we go to the original one, single transformations, give it a second. And the reason why these single transformations are important is because later on we're going to do double transformations. So we're going to do predictions on doing things twice. So now let's get into these predictions. So when we're doing these, this is also really important to do because I remember one of the unit activities talks about counterclockwise. So this CCW stands for counterclockwise. Reflections. I think it was either a activity or a mastery test I was helping someone with. So what we're going to do here is I'm going to rotate. I want to rotate about a point. I'm going to click my shape, click my point, and I want to make sure I'm on counterclockwise. And I want to do counterclockwise 90 degrees. So I'm going to do this 90 degrees. I'm going to click enter. So here, now I can pay attention to what happened to my point A. So my point A, what looks like what happened is we switched the X and Y, and my what used to be my Y switch sides. Rotations are very tricky, guys. You kind of have to like really pay attention to what's going on. So my what used to be my X changed to my Y. What used to be my Y changed signs and is now my X. So when I'm writing this down for my prediction, this is my negative Y. It changed signs and it switched. And this one, you just type in your X. And now we want to rotate 180. So again, I'm going to hide my polygon. If I want to hide my points, I can. Oh, no, I don't want to rotate. So hide my polygon, hide my extra points if I want to. If you don't, that's fine too. I'm just doing this because I want to make sure I'm rotating the right shape. So I'm going to rotate about this point, and I want to rotate 180 now. All right, so if I look at my points, I see that they both change signs and switch spots. Actually, no, they both change signs. I'm sorry. That was my bad. They just change signs. So what's going to change? Well, it's going to be a negative X, and it's going to be a negative Y. This one, I definitely recommend you guys copy this chart down. It helps out a lot in the future. So now we're going to go change to move. I don't want this E. I don't know how I made it. So now we're going to rotate 270. Again, if you want to hide it, that's fine. If you don't, that's also fine. So I'm going to rotate about this point, and I'm going to rotate it 270. All I'm doing here is I just highlight it and type in 270. It automatically deletes it, so I don't have to hit delete and do it. I think it's a lot faster and efficient. So now when I look here, I'm like, okay, so my Y doesn't change signs, but my X does. So what I'm going to do here is it's a flip in sign, and my X is changing sign. I meant flipping coordinates. So we're going to flip these. So 90 degrees and 270 both have a switch and a different type of changing signs. 360, this one's easy. It's a full circle. I'm not even going to type it in, guys, because I feel like that's pointless. You guys have probably already seen it. A 360 just means like any skateboarders out there, you guys probably seen 360, you end up in the exact same position. So that's where this happens. The position ends up exactly the same. So when you're doing this, you're going to reflect the ideas up here. So this says I'm going to swap my X and Y, swap these out. But it said that my Y, what used to be my Y changed sign. So if it used to be a negative, now it's a positive. If I look at 180, they don't switch, they just change signs. So this magically changed into 2. Put my comma in there. 3, 2. This other one, they're just opposite signs. So they're opposite signs. So it's basically the same as this, they're just opposite signs. There we go. My Y still stays negative. My X is, so this is like, again, rotations are one of those ones where I can see that you guys are kind of like switching them. All right. And this one ends up staying the same. And again, guys, I'm not going to do every single point for you, but you can always just take them from right here. And the beauty of this is they're in order. So the reason why I kind of got rid of it is if you want to fill out this chart with all the B's and everything, as long as you did everything the exact same way I did it, this should go in this spot. This should go in the next spot. Same thing over and over and over again. And again, these are going to be the exact same things here because instead of predicting it, we just did the assignment. I know they kind of want to get you into predicting, but to me, it feels like you're spending so much time predicting when you could be doing more work. So that's why I'm kind of getting into just how to do this. And for this one, when it asks, how do they compare? Basically the exact same thing as here. You're just going to have a different link. So you're just going to copy this link right here, share, again, write your name. Since this is the second time you use it, you can put like a number 2 or something to show that it's different. Wait for it to save, copy it. Then what we're going to do is we are going to paste it right there. So we're still going to write experimented a lot. So answers I can't spell are the same. Now they want us to do transformations. Transformations aren't my favorite in this, in GeoGebra, and I'll show you why. So I'm going to close this out. I'm going to open a brand new one. And I just realized we could just save this as transformations just to make it easier on us. Your name and the word transformation or translation. I'll show you guys right now what I mean. So first things first, this thing makes us want to go up. So what are we going to do when we add? They want us to add a B, right? Express your answers in terms A, B. So think of it this way. We're going to use A when we're going left and right. We're going to use B when we're going up or down. So if we're going up, what are we doing? Well, if we're going up, nothing's going to happen to my X. But if I'm going up, my Y is going to add that B. Oops. Add that B coordinate. Don't know how to hit shift apparently. There we go. If I'm going down, again, if I'm going down, my x value stays the same, but my y value is being subtracted by something. That something is this b that we're talking about. So when I'm typing this in, x stays the same, my y is going to be subtracted by that b. When we're going to the right, we're going to add stuff to the x, because if I'm going to the right, I'm going to go over here. So I'm adding b to my x. Or I'm sorry, not b. I'm adding a to my x. So this ends up being x plus a. Our y stays the same. We're not doing anything to it. We're going to the left. We're subtracting a from our coordinate. So here I'm going to write x minus a. Y stays the same. That's all we're doing. So now what I'm going to do here is I'm going up 7. So if I were to guess, I'm going to say that this stays the same, comma, we're going to add 7 to my 2. Well, I have 2 negatives and 7 positives. So that tells me that these 2 negatives are going to cancel out with 2 of the positives. So I'm left with 5 positives. There we go. Now we're going to go down. So if I'm going down, my x is going to stay the same. And then this goes down by 3. The reason why I'm not experimenting with the GeoGebra is I'll show you why. I'm not the biggest fan of translations on GeoGebra, but I'll show you in a sec. So I'm going to go to the right. So if I'm going to the right, I'm adding 4 to this negative 3, which makes it a 1. And my y stays the same. If I'm going to the left, I'm subtracting 3. I'm moving 3 to the left. So I'm subtracting 3 from this 3. So I get negative 6. And my x is going to stay the same. So I'm going to go 2. So basically, this a represents whatever we were doing left or right. And this b represents whatever we're doing up and down. Now the tricky part. They want us to prove this. So again, guys, they actually, I didn't realize that they gave us the points right here. You can just grab these and copy them. Did they do that for all of them? They did. So guess what? If you guys want to do this, you can always grab them and move them in here. I didn't even notice they did that. So what I'm doing here, guys, I'm just teaching you how to work smarter, not harder. Why go and copy all of those? Oops. I think I copied too much of it down. Why go and like keep switching the tabs back and forth, back and forth? I don't know what happened there, but good enough. When you can just copy and paste. So same thing here. I don't want to do all that work, so I'm just going to grab these. You can do it with your touchpad, or I don't know if I've ever shown you guys. If you hold shift on your keyboard and move the arrow key, it highlights it for you without you having to use your touchpad. So if I wanted to do this, for example, my mouse is way over here, but I can hold shift, Control C, click here, Control V. It just makes it easier because I know you guys are struggling with those touchpads. So if you guys ever need help learning how to navigate it a little bit easier with the keyboard, let me know. How are we going to compare our answers? Well, first I have to actually do this. So if you guys want to learn how to do a translation on here, first of all, you want to make sure you're zoomed in enough to see every individual movement. I want to move up 7. So I'm going to need a lot of room for this. So what I'm going to do is I'm going to click Translate by Vector. And I don't like this myself for me, so I can only imagine how hard it is for you guys to do it on your touchpads. So on your touchpad, you click the shape, and with another finger, you're going to drag up 7 spaces. 1, 2, 3, 4. I'm looking at the B, by the way. 4, 5, 6, 7. Now that I moved it up 7, I can confirm that I just went up 7. And the reason why I mentioned I don't like this is if you look here, I didn't go up an exact 7. I went up like a little bit, and you can see that the points don't really match up. So you can write down the decimals here. And this one, I'm going to write down they are off by a little because it is hard to move exact. And your guys' might be off by more. I'm using a mouse, so I can only imagine how hard it is to do it on a touchpad. So you can write down your decimals here for all of them. And again, they're going to be off by like a little bit. There's ways to do it using like a line and stuff, like just typing in the number if you do the code, but I don't want to get into that. I'm just going to show you guys how to do this, and you're just going to be off by like a little bit. So for the self-evaluation, I would say I had a hard time with translations on GeoGebra. Your answer might be different. That's my opinion. I think translations are really hard to do on GeoGebra. Does this activity make sense, guys? I know a lot of it was boring. It was a lot of the same stuff. Yes, no, maybe? Are you guys all asleep now?
No, I'm not asleep.
All right. Cool. So here they're just going to talk to you about how to predict the shapes. So knowing rotations, knowing this, again, you guys might want to write down those little charts, especially because this takes forever to load apparently, just because you'll have access to them when you need them during a test or something. And even when you guys tested in the center from the books, I let you guys use the little note cards just because, you know, geometry is one of those where you just want to find the answer. So you do kind of need those references. So here, this is saying study the quadrilateral, so a four-sided figure. Quad meaning four, lateral meaning sides. Which graph shows a reflection y equals x? So remember, y equals x was this line. Let me show you guys right here. Was this line right here. So this means, remember, reflection means it has the same distance. So we did that one activity where it was a 90-degree angle here. So this should have a shape over here. This B should be like over here. This C, oh, luckily lines up pretty well over there, should be here. This D around here. So we're going to end up having this quadrilateral over here. So if I look at these, the closest one to that, wait, which one are they talking about? Oh, these are all A primes. Oops. Sorry, I thought they were talking about this one. So I guess they're talking about study the quadrilateral and graph. Which of the graphs? Which quadrilateral are they talking about? I feel like they're missing a picture here. They're missing a picture here because they don't show us the original image. That's a big mistake in Mentum. How can you guys tell us to do a reflection when you don't tell me what the original? They're not. Oh, this is a pre-image. Sorry. There we go. So you guys are going to have to click this. So if I do the pre-image and I'm reflecting over this XY thing, sorry about that, guys. I was like, what are they talking about? All right. So our reflection would be, this would be our D. Our C would be about here. Our B kind of switches over here, and our A switches over here. So we're going to have this shape that kind of looks like this. And again, this is kind of my best guess of what it's supposed to look like. So let's see which one kind of matches that. Oops. Looking at it, did I do this right? I'm really bad at kind of creating these things out of nowhere, guys. So bear with me. Maybe it's a little off. Should be over there. Let's kind of compare again. My best guess would probably be the A has to flip over here. Probably be this one. I think I just kind of drew it off a little bit. I might have connected my dots a little backwards, but I'm going to go ahead and guess this. The reason being is if we're flipping over the YX axis, if you take a look at your notes, your X and Y should change. So this A should be right here. This C is 2 comma 1. So C should be at, I'm sorry, this is 1 comma 2. So our C should be at 2 comma 1. So if I look at that, this is the one that matches up the best. So I tried drawing it, but following the rules made more sense. And I didn't do that on purpose. I was literally trying to draw it out and it didn't work. But then at the end, the rules made more sense. When you have y equals x, your points flip over. So that's the easiest way to do this. So that's one of the reasons why predicting and having those rules like on a post-it, on a flashcard make the most sense. So if I'm doing this, I didn't save my answer, so make sure when you do it, you like save your work. Unfortunately, since I'm a teacher, it refreshes the page every single time, so I don't have these rules. So let's see what happens. So I'm gonna go off on the fence and just say since my x's and y's aren't reflecting, these aren't there. It looks like it's a reflection over this because this distance to here should work. And again, if I had those rules, it'd be a lot easier to do. So let me see if I can just Google those. Reflect over x axis rule. So let's see if there's an image here. If I Google it, that'll help me out. Oh, here it is. If I reflect over the y-axis, this flips. If I reflect over the x-axis, the y just changes signs. And that looks like that's what's happening. This is a negative, that's a positive. So it looks like this is my x-axis. My x-axis is that. All right, so now it's saying, how can I figure out what's happening here? I'm going to take a guess and say that it's a type of rotation because if I reflect, the only thing I can think of is a reflection here, which actually seems very legitimate because that is a distance of 1. From here to here, we can try to figure out how far it is. If I did a rotation and I were to guess, rotate 180, I'm going to guess I'm rotating 180. According to the rule, rotate 180 degrees rule. According to the rule, rotating 180 means that I'm going to flip my x and y's and the sign changes. So if I flip my x and y, that's not the case here. I'm not flipping my x and y. So it looks like this is a reflection. Oops. It did change. Sorry, guys. I keep getting robot calls. So if I look here, what's happening is the signs change, but my values flip, or my signs change, the values themselves stay the same. So I made the mistake of not really looking at this rule correctly, but you can see here, all that's happening is my signs are changing when it rotates 180. And that's what's happening here. This flipped over. All right. So now we're going to try to figure out what's happening here. So we're going to have to look at this shape. And we're saying we're going to translate it 4 units to the left. So it should stay the same size and everything. We're just moving it to the left. So this D, if it's at 2, goes to -2. That's -1. That's not exactly -2. This one's -2, though. And this should be at 0. It is at 0. So I'm going to say it's going to be graph D. So now we're going to combine these ideas together. We're going to start doing more than one transformation. So hopefully this will load in time. There we go. All right. So first things first, they want us to rotate 90 degrees from the origin. So when we're doing multiple translations, we're going to do multiple rules at one time. So I recommend having a piece of paper down so you're not having to like Google these rules every single time. So for example, I can literally just copy this and figure out what the rule is over here. So according to this rule, rotating 90 degrees, we're just switching our x and y and switching the sign of the x. So I'm going to switch my x and y, and I'm going to switch the sign of the x. So that's what's happening here. I'm just literally just copying the rule down. Now it says reflect over the x-axis. Well, guess what? I can just copy this into Google. I don't have my notes. If you guys have your notes, that's awesome. I would separate them out. Like I would, if I were you guys. Where's my track? Oh, Google. Google's very picky. It doesn't like having people write on their pages. So give me a second. I need to pick out a blank page that's not Google. What I would do is I would have like rotate your rotation rules, and then another spot that has your reflection rules, and another spot on your notes that has your translation rules. Translation is pretty obvious. If you're going up, you're adding to the y. If you're going down, you're subtracting to the y. If you're going to the left, you subtract from your x. If you're going to the right, you're adding to your x. So translation is one of those rules that it's easier to do on paper than it is to do on GeoGebra. It's very weird how it's the opposite. It's easier to do the rules there. So in this one, I'm reflecting over the y-axis. Reflecting over the y-axis, I believe just means that your x changes shape. Your x changes signs. We're reflecting over the y-axis. Yep, only my x is changing the sign. So what I'm going to do is I'm going to copy this, because first we did this, and then we're going to do something else. So according to this rule, what we're going to do is we are going to make that a positive, and we're going to leave this a negative. It's not changing. Now what we're doing is we're translating, so we're going up. So we're adding to the y. Oh wait, translation 3. I don't know why I saw this units and thought up. 3 units to the right. So we're adding to the x. So 3 plus 2, 5. We're not moving up and down. So I'm going to leave it at -1. And we're going to do all of these steps to all of these. So unfortunately, yeah, these activities do take a while. I'm sorry I don't go through all of them, but unfortunately class is only an hour long. So now we want to do this. So we can do this on GeoGebra too. If you guys want to do this on GeoGebra, great. If you want to just use the rules, it's even better. So if you wanted to do it on GeoGebra, for example, what you would do is you would click this. It already has your shapes. And oh, did it already do it? It already did some of the stuff for you. So that's even better. So rotate 90 degrees. If we look and we're looking at the rotating 90 degrees, what's our original one? Oh, I see. Here, A, B, C, D to E, F, G. So our A, B, C, D is here. Our E, F, G would be over here. So if we look, we could just copy down these points. And notice how they don't show you the stuff. If you just want to copy down the points, you could just go here, click your three dots, click algebra, boom. Now you have your coordinates to all of your points. But this one, guys, it's a lot of rules, and I kind of want to go over the last 6 slides in these last 10 minutes that we have. So just have your rules out, and that's all we're doing here. You can, again, just click this if you really just want to copy it down. That's fine. This is just an idea to get you guys used to the rules. The rules are going to be on the mastery test. Make sure you have those rules written down. So it's just talking about how these rules affect our x and y values. So if we're doing this, what series of transformations happen here? So if I'm looking at this, I'm like, this looks like it's upside down. So if it's upside down, it probably reflected over this x-axis. And then if I reflect it, it'll kind of look like this. Then what happened? Well, then it looks like it translated to the right. So I'm going to look for a reflection over the x-axis. 6 to the left. Did it move 6 to the left? 2, 4, 6, because they're going by twos? Yep. So I'm going to say that's my answer. Sorry if I'm going too fast, guys. I just realized that I'm short on time, and I want to make sure I get through as much of this as possible. Come on. There we go. All right. So this next one, how do I get from here to there? Well, if I look here, it looks like I rotated 90 degrees because if it's, so this is a positive, positive. So it can't be an entire rotation of 180. It looks like there is a rotation because this A, so let me look at this A. This A is negative 4, 6, so it would be negative 4, 6. So it looks like we're doing quite a bit of work here. So I know there's a rotation. So anything without a rotation, I know is automatically wrong. All of them have rotation. Let's think about it if I rotated 90. Well, if I rotate 90, what's the rule for rotating 90? Rotate 90 degrees. We were learning about counterclockwise, so we're looking at rotating counterclockwise. So the rule for rotating 90 degrees, again, I don't have them written down. Our y turns negative, or they flip, and the y turns negative. So if I look at my thing, let me close these out. So in this case, my point is 2, 2. So my other point would be negative 2, 2. This one would be negative 4, positive 8. Negative 4, positive 8. So I'm kind of getting this here. So I am getting this shape here, but then it looks like I went down 2, 4, 6, and then I went over 2, 4. So I went down 6 over 4. I didn't have enough time to go through all of it, but you can see that the shape is starting to form. So I rotated 90, and then I went down 6, up 4. That's wrong. Rotated 90, reflect over the x-axis, then translated 6 units to the left, 4 units up, translated 6 units to the, oh, or they're doing it backwards. They're like, oh, let's move it 6 units to the left and then 4 units up. So they kind of did it a little backwards than I did it, but you'll still end up with the same thing. All right. These again, guys, I really want to get into. Oh, it's the last one. Okay, perfect. We have enough time for this then. If I look here, this is 4, 4. This is, so it looks like not only does it rotate, it also moves. So if I were to guess here, I would say it's not, it has to be a rotation. My AD looks like it's upside down now. So if I rotate 90, it looks like it could rotate here and then it would be a reflection. Or I can rotate it 180. That wouldn't work. So it looks like it's some type of 90-degree rotation, if I were to guess. And then we're translating it as well. So I'm just going to take a guess here so we have enough time to copy it. 180. Again, sorry, I'm like short on time, guys. So they reflect, oh, that makes sense actually. I forgot we had a rule for that. They reflected it this way, flattening it out, and then they moved it that way. All right. So give me a second, guys. So the last thing we have to do for this unit, besides finishing that mastery test, is the activity. Let me go over that really fast. And while I'm going over this, guys, if you guys haven't yet, answer the question of what you've learned. That's how I'm going to take attendance. I see there's 12 of you here, but I don't see that many responses. That way, when you guys leave, I can see that you guys type something in the chat. So answer that question. The question was, what is something you learned this week? Doesn't have to be school related. Just go on the chat and answer that question. Blah, blah, blah. So give me a second here. So looking at these, we're going to do all of the rules that we just did. So what's the difference between functions and um, functions and geometry notation? Geometry notations have an X and a Y. Whenever we're doing rules for algebra, all we're doing is we're changing the X. So functions are a little different when it comes to algebra and geometry because of this. So make sure you guys are understanding how these transformation rules are affected, how this is going to affect things. Another one, let me kind of copy this unanswered, is they're going to give you these little shapes and they expect you to follow all of these rules. So I'm going to grade it based on how well you guys are following all of these rules. Like it's going to say like, oh, the fields need to fit in this plot. So obviously if you can't make them fit, then you're going to get points knocked off. If you're not following the rules where a building has to go over all the shapes, some points taken off. So that's what we're doing. So on the Google Classroom, guys, you're going to see the assignment for the unit activity due this weekend. I'm going to have it due on by Monday. You guys will have the whole weekend. But the mastery test, I do want you guys having it done by Friday. That way I just have enough time to look over it and everything. So the mastery test will be due tomorrow at midnight as usual. And your unit activity will just be due Sunday at midnight. And the post test as well. So the post test and the unit activity will be due Sunday at midnight. But the mastery test, I do want you guys to have it done by Friday at midnight. So that way, the weekend you only have to focus on these. Did you guys have any questions?
No, I'm good.
Can we just finish it before?
Finish what? Yeah, you can fit.
Time to, yeah,
You
just finish it.
you can finish it whenever you want, guys. The deadlines are there to kind of just keep pace. So if you guys want to finish the entire unit before this weekend, go for it. All right. Other than
Right.
other than that, guys, leave. Oops, let me stop the recording.